Welcome back, everyone. How did you get on thinking about the distances between the planets in our solar system? Well, in today's experiment, we're going to find out exactly how far the planets are relative to one another. I've put out this 100-meter long measuring tape that goes way down here. I'm going to start at this point here. If you remember, we used this orange balloon to represent the sun. So let's put the sun right here at the start of our measuring tape. The first planet, we used this little yellow pinhead to represent its scale relative to the balloon. This is Mercury, and Mercury would be 9 meters away from the sun at this scale. So let's walk 9 meters. 3, 4, 5, 6, 7, 8, 9. Here we go. So I'll put the little pinhead representing Mercury there so we can see it as we go further along the measuring tape. The next planet, Venus, would be about the size of this pea, and that's another 9 meters along the measuring tape, about 18 meters in distance from the sun. So let's walk out to about 18 meters along the measuring tape. Let's have a look, 18 here. So we'll put Venus right here, and I'll put another flag so we can see it as we go further. Earth would also be roughly about the same size of a pea. Remember, this scale is really approximate, but still. So that would be 25 meters from the sun. Let's have a look here. 23, 24, 25. So we'll put a flag there, and this P representing Earth right here. We used this tiny little red pinhead to represent the fourth planet, Mars, and that would be 38 meters from the sun. So we've got a bit of a distance to walk down further. So let's find 38 along the measuring tape. 38, 36, 37, 38. Here we go. So Mars would be about here. And I put this red flag here. The next planet, Jupiter, would be roughly about the size of this walnut in relative scale to the balloon at the start, representing the sun. And amazingly, that is 130 meters. So I think off the end of our measuring tape, but let's go and approximate it all the same. And remember, Jupiter is considered to be the gas giant of the solar system, but at this scale, it really doesn't feel that giant, does it? So look, here's the end of the measuring tape. This marks 100 meters from the start that the sun is. So we've got to go another 30 meters. So let's roughly count these out. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 9, 30. Okay, so very approximately, this is about 130 meters from the sun. So Jupiter would sit right there. The next planet, Saturn, if you remember, we used this hazelnut roughly to represent the size of Saturn. Saturn would be 239 meters, so 109 meters further from this point. So let's walk that out. I think I'm going to have to start approximating. We're about 200 meters now. I think 239 meters is roughly around here at the start of this path. So let's put a flag here. And our little hazelnut representing Saturn would sit right there. The next planet, Uranus, would be roughly about the size of this pebble. And believe it or not, at this scale, Uranus would be over 480 meters. And I'm afraid I've actually run out of park now. It would be somewhere by those lights down there, I think. After Uranus, of course, we then have Neptune, which also would be roughly about the size of one of these pebbles. That would be an astonishing 749 meters away. So 3 times this distance, still further on. Probably somewhere way past those buildings in the distance. And last of all, Pluto, which at this scale would be the size of a 2-millimeter grain of sand, would be over 1 kilometer away. So right down there, probably somewhere near those cranes you can see in the distance. Just think for a moment about the mind-boggling scale of the universe, with Pluto as this 2-millimeter grain of sand over 1 kilometer away from the balloon representing the sun. It honestly is astonishing that the planets were discovered in the first place. And just to think of the technology that scientists have developed, not only to photograph, but to visit these tiny planets so far away in our solar system. It really is mind-blowing. So, how did you get on? Could you work out the distances between the planets in your solar system? How did they compare to the real distances that I've measured out here? Next time you watch a sci-fi movie and see shots of all of those planets bunched together like bowling balls, think to the real scale of the solar system. It is mind-blowing to consider how far all of these celestial bodies are from one another. Thank you very much for watching, and let's find out who won this week's prizes.